Welcome to my channel Digital Vidya Team, and today we are here to discuss about the concept of Kruskal-Wallis Test, which is basically a non-parametric test. And non-parametric test is basically used when one of your variable is not normally distributed. So when your variable is not normally distributed, you cannot apply any kind of the parametric test. So for that purpose, the researchers mostly use the non-parametric test. So if you want to learn more about the non-parametric test, just like Kruskal-Wallis, so please go through the video till the end. And if you like my video, please like it, subscribe it, and make your comments. Thank you. So Kruskal-Wallis test. Kruskal-Wallis test is basically a kind of non-parametric test, and it is quite similar to one-way ANOVA. Just like in the parametric test, we usually have one-way ANOVA, like when we are having more than two groups. If we are having two groups, then we will apply the independent sample t-test. But when we are having more than two groups, then definitely we will go for the one-way ANOVA. But in case of non-parametric test in the sense when one of your variable is not normally distributed, so researchers usually go for the non-parametric test. So the concept of Kruskal-Wallis test is more or less similar to one-way ANOVA. We will apply one-way ANOVA. We basically use one-way ANOVA in the situations when there are more than two groups. So here also in Kruskal-Wallis test, we will use this particular test when in our data set we are talking about more than two samples, or when we are talking about more than three different groups. Also, it is known as the rank order test because here we are converting the interval or ratio scale into the different ordinal scale. Like we are providing the rankings, whatever variables we are having, we are providing the rankings, and based on that ranking we will apply the non-parametric test. So it's basically the conversion of interval or ratio scale into the ordinal scale. As we go by the definition, then it is used to determine whether or not there is a statistically significant difference between the medians of three or more independent groups. So we are talking about more than three or more than three independent groups. Just like in ANOVA, which is basically the analysis of variance, and here we are talking about the mean difference between the groups. But when we are talking about a non-parametric test and the Kruskal-Wallis test, then it is basically the difference among the means. Why we are talking about means here? Because we have converted the interval or ratio scale into the ordinal scale by providing the different ranks. If there are ranks involved, then definitely we cannot calculate the mean. So if you cannot calculate the mean, then you have to calculate either median or mode. So here in case of Kruskal-Wallis test, the researchers basically use the medians. Now let's start. This is a problem. This is a problem, like there are some MBA students, and they are just divided into three different groups, and each group is having let's say each group is having 10 students, and each group is having 10. The course is basically the multivariate data analysis. So at the end of the course, they have given the scores, like group 1, this is group 1, this is group 2, and this is group 3. And these are their scores. So now let me show you how will you apply the Kruskal-Wallis test in SPSS. So let me share the SPSS first. Stop share. SPSS files, share screen, and this is my SPSS file. So here if we go through the variable view, so this is basically representing the different this variable one is representing the scores the different students are having in that test, and this variable is representing the group 1, group 2 and group 3. Now the question is, how will you apply the Kruskal-Wallis test? So firstly you will go to the analyze, then you will go to this non-parametric test, and then we will select on the legacy dialogues. In legacy dialogues we will be selecting this k independent sample. Why we are going through the k independent sample? Because we have to apply the Kruskal-Wallis test, and it is applicable when we are having more than 2 groups. So we will select this now. Our variables are like first test, this is basically the test score, so it will come under the test variable list. The second variable, which is a nominal variable, which is actually representing the different groups, so I will be selecting it here. When you will put here, it will ask for define range. So we have taken minimum 1, like 1 is representing group 1, 2 is representing group 2 and 3 is representing group 3. So minimum is group 1 and the maximum is group 3. So I will put the range 1 and 3, and then I'll continue, and then I'll simply click on options and I'll check on descriptives, but by default it is checked, so we will just continue it, and then I'll click on OK. Okay, stop. One second, let me share my output file, and this is the output file. Yes, so from this table we can see that there are different descriptives. Like first descriptive, the first table is representing the descriptive statistics. Second table is representing basically the ranks, like group 1, group 2 and group 3. Now coming to the test statistics table, and from this table we can see that there are the significant value is coming less than greater than 0.05. If the significant value is greater than 0.05, it means we are actually accepting the null hypothesis. And what is null hypothesis? There is no difference between the group medians. So in this particular case you can say that all the groups like group 1, group 2 and group 3 are similar, or the scores or the marks obtained by the students in group 1, group 2 and group 3 are similar. And why? Because this significance value is coming more than 0.05. Now let me share second question. Now coming to the second question, this is the second question, and this is the following data set were collected, which are the achievement test score for 4 different groups of students, and each group taught by different teaching techniques. So basically in this question there are 4 different groups, and these are the marks obtained by the students. Now the question is, you have to apply, firstly you will check the normality, and we have already checked the normality. We are not getting any all the groups, the variables are not, means basically the scores are not normally distributed. So these are the 4 different groups, and we have to identify whether the groups are same or different. So for that purpose we will be applying the Kruskal-Wallis test. Why we are applying the Kruskal-Wallis test? Because the distribution is not normally distributed, variables are not normally distributed, and second, there are more than 2 groups. So we will apply the same procedure, and one second, let me open this SPSS file. Yeah. So how will we proceed? We firstly go through the analyze, then we will check on the non-parametric test, and then the legacy dialogues. Legacy dialogues and the k independent samples. So let me put it here. So scores is basically we have to identify whether the different students have scored differently or same. So what will be our null hypothesis? The scores or the marks obtained by students in different groups are similar or equal. And what will be my alternative hypothesis? The marks, the median marks, basically the marks obtained by student in different groups are different. So I'll put score in test variable and the groups in the different grouping variable. Define range, we have to define the range just like here we have defined the groups, group 1, group 2, group 3 and group 4. So basically there are 4 different groups, so I'll put define minimum group 1 and the maximum is basically the group 4. I'll click continue and then I click on OK. Now let me share my output file. This is the output file. Yeah, so this is my output file. Here we can see that this significant value, this significant value is coming 0.02, means which is less than 0.05. If it is coming less than 0.05, it means we can apply the it means all the groups are different, or the marks or the scores obtained by students in different groups are different. Now here we have identified one thing, like groups are different. Just like in ANOVA, we usually conduct post hoc test, that is a Tuckey's test, in order to know which two groups are different. In the same manner, in Kruskal-Wallis Test also, we can check which two groups are same or which two groups are different. So how will you check it? We will go to analyze and then we will check on non-parametric test, then legacy dialogues, and then we will click on two sample independent t-test. Now I'll define groups. Like firstly I am comparing group 1 with group 2 and then I'll click on continue and then I click on OK. Based on the significant value which is coming here, it is 0.534. It means group 1 and group 2 are not statistically significant, means there is no difference in the marks obtained by a student in group 1 and group 2. Now coming to the next, we will compare other groups, like here we have compared group 1 and 2. Now we will compare group 1 and 3. I'll click on continue and then click on OK. Here also we can see that the significant value is coming 0.394, which is greater than 0.05. It means we are accepting the null hypothesis. So group 1 and group 3 are also similar. Now again we will compare non-parametric test, legacy, and then two sample independent. We have compared group 1 and group 2. We have compared group 1 and group 3. Now we will compare group 1 with group 4. When we will click on continue and then click on OK. So here we can see that the significance value is coming 0.018, which is less than 0.05. It means that group 1 and group 4 are statistically, or you can say significantly different from each other. Now we will make the comparison among the other groups, legacy dialog, two sample independent, and then 2 and 3. Firstly I'll compare group 2 and group 3. So group 2 and group 3. Group 2 and group 3 are almost, there is no statistically significant difference between the group 2 and 3. They are almost coming same. Why? Because the p-value is coming greater than 0.05. Now I will make the comparison between group 2 and group 4. So two sample independent t-test, I will define groups 2 and group 4. I'll click on continue and then I click on OK. So from here we can say that both the groups, like group 2 and group 4, are statistically and significantly they are different from each other. Now coming to the next, that is we will be comparing the we will be comparing the group 3 and 4. Now let's check the value what is coming, which is less than 0.05. So what we can conclude from here, we can conclude that in case of second example, like group 1 and group 2, they are same, means marks obtained by group 1 student and group 2 student are almost same or similar. Marks obtained by group 1 and group 3 students are also same. Marks obtained by groups 2 and groups 3 are also same. But in case of group 2 and 4, group group 1 and 4, group 2 and 4, and group 3 and 4, they all are different. So this is all about the Kruskal-Wallis test. So thank you.